Gloria Brooks here. Today we'll be learning about the golden ratio and Fibonacci numbers. Think back to a time where you may have heard those two terms. Haven't heard of the golden ratio or Fibonacci numbers? Well, let's talk about them. So the golden ratio, it is a number that is infinite. It goes on forever. But when we talk about the golden ratio, it's represented by the number 1.618. And if you have a journal or you have your student study guide with you, you can go ahead and write that number at the top so you remember. And I'm just going to put dot, 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 dot. Do you know what that represents? Go ahead. Yes, it represents infinity or going on forever. So this number, 1.618, has been found in all kinds of interesting and mysterious places. Sometimes it's found in nature, but most of the time people use the golden ratio in creating art and architecture, especially in ancient Greek or ancient Egyptian architecture. There's also an example of this beautiful ratio found all over the world, such as in India, Africa, Asia, all of the continents. People have created beautiful architecture and art that utilizes this number. The next number we'll be learning about today are Fibonacci numbers. Okay, and if you have your journal, you can go ahead and write this in the journal, Fibonacci. Fibonacci numbers. Now, Fibonacci numbers are 1, 2. 1 plus 2 is what? That's right, 3. 2 plus 3 is what? 5. Awesome. 3 plus 5 is what? 8. Terrific. 5 plus 8 is what? It's getting harder. That's right, though. 13. On and on it goes. So this is also an infinite number. This is the golden number represented by this chambered nautilus. Now, this could be a little tricky because most chambered nautilus actually do not exhibit the golden number, golden ratio. So another name for the golden ratio is golden number. It actually has a multiplicity of names. Just like I showed you earlier, the golden number is mathematically defined as 1.618,033, and it is an infinite number. It has been used since ancient times for making beautiful buildings and statues, works of art, and even religious temples. And it can sometimes be found in nature, but usually nature has approximations, but can be found sometimes in seashells, such as this chambered nautilus, plant growth, like spiral growth patterns found in plants, the human body, such as the human ear cochlea that helps us hear. It's in the shape of like a snail, and human body proportions. The golden ratio mathematical proportion diagram. So here you can see when we divide this line into two parts with the whole length divided by the long length, which is also equal to the longer length divided by the shorter length. This is like the mathematical formula that helps creators be precise in using this beautiful proportion in their art. Examples of the golden ratio are found in nature. Another nickname for the golden ratio is phi, and it can be found in many aspects of life in the universe. Following are several additional examples, including the human body, DNA spirals, a human embryo, teeth, proportions. Here are some examples of the golden ratio in art and architecture. The Mona Lisa, you can draw a golden rectangle around her face. Also, the Greek Parthenon, you can draw a golden rectangle around it. Go ahead and take your finger and trace it around the Mona Lisa first, and then take your finger and trace a golden ratio around the Greek Parthenon. Pretty cool. The golden ratio can also be found in music. And also there are artists today that create music within the golden ratio. So music is composed of numeric value, and when the golden ratio is used to create a musical piece, it becomes a living example of math. The numbers of black keys on a piano are Fibonacci numbers. So here are some composers who use the golden ratio and Fibonacci number sequencing in their musical pieces. Perhaps you have heard the music of Bach or Beethoven or Chopin, Claude Debussy, Liszt, Ravel, Schubert, Wolfgang Mozart, and this wouldn't be complete without at least one modern day golden ratio music producer. Modern composer Casey Mungovan explores and uses the golden ratio and Fibonacci number sequence in his music. And Fibonacci numbers found in flower petals. Look for a flower exhibiting 5 or 5 petals. If you said buttercup, that is correct. How about 8 petals? That would be Paris japonica. And finally, 13, we are left with the black-eyed Susan. So that's how you can find Fibonacci numbers right around you, right in your own backyard. You'll probably find flowers with petals that have Fibonacci numbers. Thank you for watching.